Alright, so we're going to do 1.7, which is inverse functions. I'll go ahead and apologize that this document in front of me isn't the clearest, but hopefully you have this paper in front of you, so if the numbers and letters don't look perfect on the screen, you can see them clearly on the paper you have in front of you. So I'm going to work a couple of these problems, and hopefully they'll make sense. So as we go through this, for inverses, our rule is that I'm going to take x and y, and we're going to switch them. An inverse just switches the x and y like that. Okay, so we're going to switch x and y. So that means that if I had x and y over here, and I had 1, 2, 3, negative 1, 0, 1, then my inverse would be x. We'll put a little y, negative 1 to show this an inverse, and I would switch my x and y. So my x would be negative 1, the y would be positive 1. The x would be 0, the y would be 2. The x would be 1, the y would be 3. You see how I just switched each individual x and y. So that one became that. Okay, so an inverse is just switching the x and the y. Well, that's great if I have just a coordinate point or maybe a list of x and y values, but what if I have an actual function? Okay, well, the first thing I want to do is think of this as y and x. It doesn't matter what variable they give me, I'm going to change this, the f of whatever, to y, and then the variable to x. Next, I'm going to switch my x and y. So x is 3 over 8, y minus 15 over 8. Okay, so the first thing I did was switch, first thing I did was wrote x and y, and then I switched my x and my y. And now this is the inverse, but I need to solve it for y. I'm going to try to get y by itself. Well, let's think about how could I get y by itself. I could add 15 over 8 to both sides. A little dividing line. And that means I would have x plus 15 over 8 equals 3 over 8y. And then for this next step, there's really two different ways I can do it. Some of you are looking at this like, man, there are fractions in here, I don't like fractions. Well, there's actually a way I can get rid of the fractions, because I see both of them have a denominator of 8. So I could just multiply both sides of my equation by 8. If I multiply both sides of my equation by 8, well, when I multiply 8 times this one, the 8 and the 8 cancel out, and I'm left with 3y. On this side, I'll distribute the 8 to the x and get 8. Oops, let's do that in a way that you can see it. I'll get 8x. When I distribute the 8 over there, that 8 and that 8 cancel out, and I'm left with just plus 15 goes through y. Now I can look at this and be like, oh, okay, all I need to do to solve for y is divide both sides by 3. If I divide by 3, I'll come over here and say I got y, and yeah, I just switch sides of the equation. Y equals 8 over 3x, because I'd said 3, and then I said, well, 15 divided by 3. 15 divided by 3 is just 5. Alright, and I have this equation. And the last thing I'm going to want to do is, well, I changed y, or I changed f of n to y, so I'm going to change it back. And I'm perfectly okay with leaving them in terms of x, but I need to write it like this: f of negative 1 of x okay, So that little -1, get my little highlighter out, that little -1 you see right there, that's what tells me that my final answer is an inverse. So the fact that it has that little -1 tells me this is the inverse of f of x. And to be maybe more correct, I would say, okay, well, since the original was in terms of n, I could put an n there instead, but if you want to leave them x's, that's fine. But that's how I do an inverse with a linear problem. One thing I will say is back here at this step, you maybe were looking at this like, oh, instead of multiplying by 8, I could have just multiplied by the reciprocal of 3/8. So I could have multiplied right here, instead of multiplying by 8, multiplied by 8 over 3, and you would have done 2 steps in one, and you would have just instantly gotten that, and that's perfectly okay. But I wanted to break them down into steps to show what all I did. But if you wanted to distribute by 8 over 3 to cancel out 3/8, that works great. Alright, so there's number 1. I'm going to skip on down to the next type problem. Which is going to be number 4. Number 4 is a little different. So number 4, there's a 5 up there. It's not very clear on mine, but you should be able to tell it on yours. So I'm going to do it the same way. Y, and there's already an x there, but I'll write it and make sure it's clear. Then I'm going to switch my x and my y. Y minus 1 to the 5th. And then I need to solve for y. Now you might be looking at that exponent like, oh, okay, we need to take the 5th root. And we will, but I have to get rid of that -2 first. So I got to divide by -2 first before I can do anything else. So that gives me x divided by -2, or -1/2 x, equals y minus 1 to the 5th. And so now I can look at that and say, well, I have the power of 5 there. Well, if it was a squared, I would take the square root to get rid of it. So since it's a 5, we're going to take the 5th root to get rid of it. So I have the 5th root of x divided by -2 equals y minus 1. And then I need to say, well, I'm still trying to get y by itself. It's really close, but not completely there. Add 1 to both sides. And my 1's not going to go inside my radical, okay, because I'm not doing the 5th root of 1. It's just the 5th root of that. So to show that my 1's not inside my radical, I like to put the 1 first. So I'm going to say 1 plus the 5th root of x divided by -2 equals y. If you look at the correct answer, they probably have it backwards, but I like to put the constant in front just to show that it's not inside the radical. And then I'll write my final answer, because I want to change y to f -1. So this is the inverse of 1 plus the 5th root x divided by -2. Okay. So that's how I do one like that. We'll move on to one that looks a little different. Probably number 6. So number 6, as far as graininess, is really bad. I'm going to assume because there's a plus, a -1, and a +2, that this must be the cubed root like that. And hopefully that is in fact the cubed root. I'm going to pretend it's a cubed root there anyway. So if that is the in fact the cubed root, we'll say, well, there's y, here's x, switch them. If I switch them, I get x equals the cubed root of y minus 1 plus 2 minus 2 from both sides I need to get rid of that cubed root. Well, so the opposite of a cubed root is to actually cube it. So there we go. That gives me x minus 2 cubed equals, well, the cubed and the cubed root cancel out, so equals y minus 1. I'm going to add 1 to both sides. And again, I cannot add the 1 inside that parentheses because I'm not cubing the plus 1. So I'm just going to leave it x minus 2 cubed plus 1 equals y. And then to write our final answer, I'm going to say f, or actually, no, just to stay in the same context of what they gave me. They gave me g of n, so I'm going to write g to the negative 1 of n minus 2 cubed plus 1. If you put f to the negative 1 of x and then x, that's fine. But I just want to try to make sure I'm showing my answer in the context of the problem I was given. So that's how I do number 6 and other problems that have roots in them. I'm going to scroll down. Try one of these. I'll go with number 7. So y, x already has x in it. Switch them and I get y equals 2 over, no, messing up. Sorry. X, didn't switch the x and y. X equals 2 over y plus 1 minus 3. I want to get rid of the y, or I want to get the y by itself, which means moving it out of the denominator. But before I can do that, I need to get rid of that minus 3. So I'm going to plus 3 on both sides. And that's going to give me x plus 3. Okay. And at this point, most people try to get rid of the 2. We're actually going to leave the 2 right where it is and actually get rid of the y, because the y is in the denominator, and I don't want it to be in the denominator. So I'm going to multiply both sides by y, the denominator, which in this case is y plus 1. And same thing over here, y plus 1. And I'm not going to actually FOIL that out. I'm going to leave it just like it is. So I'm going to leave this as y plus 1 x plus 3 equals 2. Then I'm going to divide both sides by x plus 3. Those cancel out. I have y plus 1 equals 2 over x plus 3. My last step will be to subtract 1 from both sides. So I end up with f to the negative 1 of x equals 2 over x plus 3 minus 1. And there's my inverse. Alright, and so if we continue on up here, let's see, we did one like that. Alright, are the given functions inverses? So, two ways you can do this one. One is you can actually just find the inverse of one and see if it matches the other. But what they want you to do is composition, which is what we did yesterday. And so, this is how one of the ways we apply composition. We're going to find f of g of x, and then we're going to find g of f of x. And if both of those equal just x, so if I can simplify those down to be just x, then I can say yes, my functions are inverses. If they're not, one or the other, then it's no. So let's find those. We'll start with f of g. So I have my f is my outside function. I'm going to write it down, put parentheses wherever there's an x, cubed plus 1. Okay. Inside those parentheses, I have the cubed root x minus 1 plus 1, and then I'm going to simplify. Well, that 1 right here and this 1 right here, positive 1 and negative 1, those cancel out. So I'm left with the cubed root of x minus 1 plus 1. Well, when I cube a cubed root, those cancel out, leaving me with x minus 1 and then plus 1. And then lastly, the minus 1 and the plus 1 cancel out, and I'm left with just x. So that tells me that this is most likely a inverse, but I do need to check it in both directions. So put a line right there. Let's try g of f of x. That would be the cubed root of parentheses minus 1 plus 1. Inside those parentheses, wow, I didn't leave myself much space. Let's try that again. Come down a little lower. Alright, so g is the cubed root of, I'm going to put parentheses and I'm just going to go ahead and stick it in there, x minus 1 cubed plus 1. Alright, so that was the x. So it's the cubed root of x minus 1 plus 1. There we go. Alright, and this should work fairly similar as the left one. So I see these two values cancel out. I'm left with the cubed root of x minus 1 cubed. Well, the cube and the cube cancel out, and so I'm left with x minus 1 and then plus 1. Those two values cancel out. I'm left with x. So because both simplified to x, yes, they are inverses. If I would have gotten something that simplified down to be, say, 3x or x minus 5 or something that's not just x, that would be an example of a no, not inverse. Yeah. No, they are not inverses. Okay. Alright, so all those are the same way. And then let's look at the graphs. Let's see, what two graphs do we have here? Alright, we'll look at one like 14. Well, actually, no, it'll be easier to do 16. Let's do 16. And then maybe I'll go back and do 14. This one might make a little bit more sense. Alright, so I have this right here. I'm going to find its inverse. So I'm going to say that's a y. So I have x equals 2y divided by 2 divided by 2. Okay, so I have y equals x to 2, which for graphing I'm going to change to that because that'll make it easier to graph. So if I try graphing them, I'm going to let my original one be blue. If I graph it, they both have a y-intercept of 0. And this one has a slope of 2x. 2, 2, 2, 2, 2, 2. So we'll try to draw a straight line through those points. And that's where I'm going to have to stop because the bell rang. My next one, if I go quickly, up 1 over 2, up 1 over 2, up 1 over 2. and that's how I graph inverses. Inverses are always symmetrical about the line y equals x. Alright. For this one, I graphed this one on the board by hand. The other two, you're probably going to want to use your calculator to graph those. Alright. Good luck, and I will see y'all when I come back.